Monday. I was just saying Monday because this week is messed up. So, all right. So what's fun for Fun Friday? Where is Jesse? He's not here. Yeah. Cool. So are you going? You're in it? Wait, who else? No. What are you guys doing? And girls, nothing? Nothing fun? Like I know you have to study, but anything fun? There's game. It's fall season. You can go for a walk. It's nice before it gets all rainy and snowy and muddy, right? Okay. No shameful videos. I haven't fell, so they can't do anything. All right, so Monday is the exam day, right? So you will have access to this on Sunday morning. Basically tells you that you have exam 1 in person here, and whatever is inside of it, it's inside of the lecture that I'm going today, like the review. So before we start on the review, I want the graduate students and the undergraduate students group themselves for PA2. How do you do that? Is everybody listening? I'm recording this, so don't come and ask me again. I mean, come and ask me, but try first. Like, I'm not that mean, but. So if you're a graduate student, you go here. You should know each other before you go and sign up your names, right? You don't want to be with random student. If you're a graduate student, raise your hand. Raise your hand if you're a graduate student. Okay, look, stand up. Okay, let's just do that. Stand up if you're a graduate student. It's fine. Nothing is gonna happen. All right, stand up, stand up. It's not here. There is no more on here. So you're gonna be in teams of 2, so, right? But it has to be viewed with someone. All right, sit down. You will find out the person's name. Well, you basically go here and then sign up for graduate team 1 if you're a graduate student. So all the way to team 4 is 8 of you, so it works perfectly. If you are an undergraduate, I don't care if you're friends or not, it's the work that needs to be done, right? So either ask about your background and what's your work schedule, so you can work together. If you're an undergrad, which is the rest of you, I'm not gonna make you stand up because it's ridiculous. But if you want to stand up, you can. If you know each other and want to be in teams, go ahead, sign up, right? There is 21 team of 3 and 1 team of 4 because it's odd number of the students. We might actually, yeah, it's 95 of you, 34 of you. It's even number now. I think 1% dropped. So, but I leave it there. Don't go like sign up for team 21. Start from top, fill them out, right? So either talk to, hey, Michael, I want to meet you on my team. Yes, let's go grab one you want. 4 of you, 3 of you will sign up for that. Yeah. It should be self-sign up. It's not. Yeah, it's undergraduate, but I'm not interested. I might not have a self-sign up. I'm gonna make a self-sign up. I will self-sign up. Yeah. I think I did that for the graduates. Yes. Yeah, undergrad and don't pay attention to that. All right, so you should be able to do that. Now, once you figure out your team members, you're gonna work together with the assignment. The assignments are going to get larger and larger. It means that you have to work together. Now, if 2 of you work and the other one slacks off, you tell me from the very beginning. Don't leave it until last moment. Don't be like, oh, I want to be good to this person. They have problems such and such. It's okay. I can be good to that person, right? I need to understand and accommodate them, not you. So once you have your teammates talk to each other, what's your approach to solve that problem? And then once you code it all together, you all need to sit down and understand what the code is doing. There will be 1 grade per team for all the assignments. So I'm assuming you're working like 1/3-ish of the project. someone is good in GUI development and front end, someone is good back end, someone is good at understanding the problem, the model from the physical model I gave you to mathematics part of it. You figure out and work together, all right? I'll talk about the P assignment next week. I'll explain what I'm asking, but you can read through. It should be straightforward, especially after all the points you got on P assignment number 1, right? Because this is kind of simple math. So you know what you should do. Clear? You can do that later. Don't do it right now, but just wanted to make sure that I hit that. Now, for today, so this will homework 2 solution you should have access to. All right, where am I? Here. So what does the exam cover? This is part of the exam, if you want to listen. Lecture 1 to lecture 13. Now, lecture 1, the beginning, I'm explaining what Carmen is, what course is, not that part at the end of it. Until end of lecture 13, again, if something requires big calculation, you know it's not going to be in the exam. It's 55 minutes, right? All the CPs, CP2 to CP10 quizzes, whatever was in between, you have all the solutions. Practice problem I posted. Take a look at them. They have solutions, especially if they have solutions. Take a look at them. All right. You can bring 1 page of cheat sheet. What is a page? This is a page. 1 side. All right. You can write on 1 side. This is called US letter A4 size printer paper. Any of them, same thing. Now, do you have to write by hand? Do you have to type it, copy, paste? I don't know. Whatever is best for you. You can do it in your iPad and print it on the page, also acceptable, right? I want you to study. I don't want to just last minute copy pasting bring here because it won't work. Next thing, you can only bring equation and formula. You cannot have solved problems. So you cannot have 2 frames and then some orientation and write, this is the rotation matrix for these 2. Oh, that's just an example. It's not going to be in the exam. You don't know. It could be. I don't want to leave any doubt. So it might be previous class. I'll go check your cheat sheet, and if it's something that I know is on the exam, I tear it apart. If you're in my robot control class, you know I've done it. Because anything you bring with you would not get you a point. So just simply writing the formula on the exam sheet doesn't get you anything because you brought it with you. And then you give the cheat sheet to me as part of your exam. When I grade it, I'll read this back to you. If you want to keep it for exam 2 and final, you have it. Does that make sense? And actually go through it. Sometimes I will write it for you. You have the formula in your cheat sheet. You didn't know. And I'm helping you. So I kind of, you maybe not a saver, just wrote things. Next, don't do that next time. Okay? So why am I doing this? I think it will help you how to study. Right? Because you need to rely on yourself in the exam. My exams, if you understood what the course is about, what the content is about, the exam is easy. If you didn't understand what's going on, the exam is confusing. All right. So learn the concept. Say, what is forward kinematic? You want to know what forward kinematic is. Right? We talked about exponential coordinates, how to represent it. You want to know that. We talked about the states of a vector, for example. You want to know what that is. All right, it's not just find the degree of freedom of this thing. Yeah, I know that would be part of exam, and you also know that's part of exam. So I'll save some portion of the exam for conceptual questions. Okay. Any question on the logistics before I go to the exam part? All good? Yeah. Do you have a question?
Yeah, so I know you mentioned, like, obviously we have different methodologies, say like rotation, having multiple methodologies. For like the centric things, I know like axis angle is pretty heavy, like calculation based thing. Would we need to have all of the equations set for that on our equation sheet, or is that something that we provide to us? Like
I do not provide. Okay, here's what I provide. That's how page 1 would look like. I'll give you sine and cosine. It's going up. Sine and cosine of some angle. So because you're not bringing a calculator, right? and there's gonna be angles in there. Of course, we're talking about rotation. It's gonna be one of these angles, or they're complementary, or you're able to find the solution knowing these. I'm assuming you know a little bit of trick, remember, all right? So, if you think axis angle is going to be there, bring the formula, right? All the formula that I gave you, how to calculate the axis, how to do the angle, sine of something, bring all those, just the formula. And then when you have the question, you can use it. Good. If you have your cheat sheet at the end of the class, you can bring it to me and I can check. I can stay a little longer today, so I cancel everything. Make sure that you're prepped for the exam. All right, read these through. It's gonna be the same page, basically similar things that I can say. I said no phones. So you come in, you're doing your last readings because you want to make sure that you're like 100% ready. And then I say, okay, put everything away. You put your phone, calculator, notes, everything in your backpack on the floor. It's you, a pen, pencil, your cheat sheet, and eraser. If you need extra paper, I'll give you. I left one page at the end of this empty. These are all printed on one side. So you have 4 pages of blank plus 1 extra page of blank. That should be enough. I will have extra A4 size. All right. If you don't sign this, you'll get a 0. This means that you agreed you're not going to look at some, because I'm going to be sitting down, put my head down, do my thing. And trust me that you're not going to look at each other's hand. All right, I will space you out. But then after that, like trust. So you're telling me that you can trust us, and that's enough for me. I might even step out of the room. Okay, so you have to sign, write your name, first and last name. Then you will get to short answer questions, 10 points. There will be 5. 3 of them, I even told you what they're going to be about. 10 easier, right? So something about degree of freedom, something about rotation matrices, something about forward kinematic, something about exponential coordinate. We talked about those two. And something about calculating some rotation matrix. So the question 4 and 5, you see there are 3 points. There is there's some calculation in there, but very straightforward. So I'm not giving them too many points because you bring the equation, you just have to plug in numbers. All right. So you want to be careful with your answers. Don't have it like a mathematical mistake or calculation there, because I don't think you're going to do 1 point and that's a big chunk. Then you're going to have your problems. There are going to be 3 problems. Problem 1 will be a mechanism that you calculate degree of freedom. Problem 2 would be something about transformation matrices, right? So it could be find this like your homework, different transformation matrices. It could be a point that you're transforming to some other places, right? So don't forget P is equal to T times P or R times P, right? Make sure you have all those equations in your cheat sheet. So something about this. I usually ask, show your work. So if, first of all, I need to know what was your train of thought. Second, if you're making a mistake somewhere, it could be a stupid negative number. You just point for that, or sometimes I'm in the good mood, the beginning of reading, I'll just the end, like I divide them in times, so I'm fresh for everyone. But if you show that, you might lose 1 point versus I don't understand this. Okay, have fun, like 5 point taken. I should not be looking for the answer. If I tell you that, what do you think? What does your finding tell you about your solution? I mean, look at the solution. Does this make sense? Look at your system. Explain to me. All right. So everything always has to make sense. We will solve this. I'm just going to show you question 3 so you know all the questions, and then we're going to go from the top. 1 question about forward kinematic. Answer only what I asked. It's in your homework. There are 2 questions. I asked different things. Same here. I graded cost participation 9. There were 6 joints. A handful of you counted 4 joints. So check the solution. There are 6 joints. Some of you said 7 joints. You counted end effector as a joint. So A quick disclaimer, end effector is not a joint. End effector, what is end effector? If this is a robot, where is the end effector? The fingers, right? Anything after wrist. So any industrial robot, any manipulator robot you see, there is a joint that is called wrist. And anything after that is end effector. Why? Because in robot, you can take this off, put something else, depending on the work that you're doing. If it's graphing, you're not gonna have 5 fingers. It's usually 2 paws that pass, right? If it has to have tactile, then you might have finger and then some sensors on the tip to measure force and blah, blah, blah. So that's why we usually solve up to wrist. End effector is whatever is gonna get connected. So it's usually a frame, means it ends here. Does that make sense? So you don't have to write, it's not a joint. We only write our screw axes for our joints. If something is not a joint, then you don't have to write a screw axis for it. It doesn't have rotational translation. So that will be your third problem. Now, you'll see this, so this is similar level of difficulty. You have 55 minutes. You have to manage your time, decide how much time you spend. My suggestion, if it doesn't like scare you, look at all the questions and then answer the ones that are very clear to you first. And then leave the ones that need more work for the end. So you know that you've got some points and then you're working through the rest. If this doesn't work for you, it's fine. I'm just saying that you have to answer all of them. This has a more point, 25, but the other one also have their own points. So if you are a person that wants to get the most out of this, like grade-wise, so you want to do very good on this. There's no makeup exam, I don't care, nothing. Any questions? Write neatly so I can grade easy. If I don't understand what you wrote, I don't give it a point. Yes. That's it. All right, so let's go back from the questions that we have. So spend some time, 5 minutes, solve this. Everyone should be writing. You can check your lectures if you forgot the equation or you have the cheat sheet, make sure you have the information there. Oh. Prismatic joint seems to be the problematic joint. I work hard on that. Nobody like you did a little.
Yeah.
Oh my God. Tough crowd. I'll be tough grading. How about that? I will laugh. All right. So ground always counts as one. Doesn't matter where your grounds are, right? So this is your ground. Ground is usually shown by the hash. I don't know what is it called. So this is link one. Now you can start one side and go to the other side. So I like to identify my joints first. I don't start from the links, but I always identify the ground, so I know that's one. So I usually say ground plus all the links. This is a joint, is a prismatic joint. It has the thing. Prismatic joint, revolute joint, prismatic joint, right? Now, every joint has to connect to links. So that was ground. I'm starting from here. Ground, this is prismatic joint. So this is one, right? So this is one whole link. This is the second prismatic, is a sliding inside this channel. So one side of the slide is on this channel. The other side is this handle. One joint here. This revolute joint is connecting this handle that I already counted to this plate. The other revolute joint is connecting this plate to this arm. Then this is a sliding inside here, and I already counted ground. So 1, 2, 3, 4, 5. So link is 5 plus 1. 1 is ground. G and D for ground, 6. And then for joints, I have 2R plus 4P joints, that's 6. Sigma Fi, 2 times 1 plus 4 times 1 is 6. DOF, 3 times 6 minus 1 minus 6 plus 6 is 3. You see how I write in detail? And anytime, anywhere I make a mistake, you can catch it and draw points. Now, if you do all of them in your head, don't even write numbers, and then put DOF is equal to 5. I'm not gonna give you much out of 10. I'm gonna give you like 3, maybe. Or 2, because you could have, well, you said you're not, but you could have looked from someone else's hand. And then you just like randomly mark. Or you provide a way for me to give you feedback and teach you. Either way, you can look at it either way. So I would be a liar if I say, I don't think that you might. All right, but it's both ways. So you want to show your work to give yourself credibility and help me to help you. Now, read question 2 and solve that. I'll give you 10 minutes for this one. So I'm giving you idea how much you have to spend on these questions as well, right? Who You think of. But we won't need it. Wine today. So. All right, anybody got conclusion? Trust your calculation. Find it? I'm so confident. No. You would know, if you find that, you would know what I'm asking. And find out. Oh, I mean, they- What is really important, and I'm giving you a hint, well, I'm helping you. PES is given to you. You're trying to find the coordinates of origin of frame S as seen from frame R. You're trying to find what is RPRS. As seen from this origin, so. Now, try to solve it. Be able to read the question and understand it. Yes.
Yeah.
But they will get down to, oh, two that I know have the solution. I'm just gonna go for it. So we have PS, we need PRS. We know that we can write this relationship. PRS is TREPES because I'm trying to find PRS on the left-hand side. Now I have this. I don't have this directly, but look at here. TRE is the transpose or inverse of TER. Now, do you remember how to do this? You can't just put in your calculator, you don't have it. So you have to use that formula. So yes, RER transpose, negative RER transpose, PER 0, 1. Also, remind me to explain that thing at the end, that one thing at the end. So why am I doing this? Why am I not letting you bring your calculator? Because I want you to be able to identify which one is RER, which one is REP, right? From the transformation you have up there. If you had your calculator, you will put it in inverse, you don't know what happened. So now the rest should be easy. You find your TRE, then you have to do this. You have to say, well, this is 4 by 4. So PRS 1, that 4 by 4 TER inverse times PES and 1. Making sure that you append 1 because it's a point, right? This will give you 0, 0, 0, 1. Now, PRS is 0, 0, 0. So you don't end up here. You have one more step to go because it's XYZ coordinate. Now, what does that mean? PRS 0, 0, 0. You're trying to find what the original frame S with respect to frame R, right? What is S? Here. What was the point that we had? PS. Don't know each other, right? Same origin. So your solution, like if you see something like this, it's like, oh, why they're all zero? There is an explanation. You could find it and it will give you. If you get something really wrong and you're like, oh, I'm out of time, but I know it should have looked like this, write it down. Like you tell me, you expected you knew what to expect, it just the calculation didn't match. That worth more some points than, give me the wrong solution, I don't even look at it. So, interpretation analysis is important in robotics. Everything you saw, you have to think about. So I'm making sure you do that from the very beginning. So. I think your question is easier than this one, to be honest, for your exam, but this was an exam one then. This question, read quickly and tell me what would you need to calculate? Huh? The screw axis, right? Which ones are the screw axes? The vector one, 6 by 1. You don't have to calculate the matrices for this example and all the bracketed and automatic, right? Now, there is an interesting point in this example. That's why I give this one. Let's identify all the joints. So this is your frame 0, and I've explained what is what. So this is your frame 0. This is joint 1, joint 2, joint 3, and joint 4. So we know this is going to be Z1. This is going to be Z2. This is going to be your Z3, right? And this is the direction of Z4. Let's say that you want to put the origin here. You could also put the origin of that. You could assume if you look at the solution of homework 2, you see that in the last one I said, if you are not given the origin in the same direction, you can move up. But let's say you didn't want to do that, you were not sure, you want to put it in this way. All right. Now, if I was going to write, first of all, what is M matrix? M is the position of this guy into the base frame, right? So ZXB, there's no rotation, right? So 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0. Then we know, well, this is the origin of B, OB. This is OO, O0. It's going to be 0 in X direction, so it's not extended in this direction. It's L0 in Z0 direction, and it's L1 plus L2 in Y direction, right? That's your base, that's your home position. So that's the first part, home configuration. Now you have to write screw axis in frame 0. So you have to create that table. Omega I, sorry, I, omega I, QI, VI. 1, 2, 3, 4. I know this one is prismatic, so I don't care about Q. I don't care about VI, right? So you can kind of fill it out for yourself. Then when you look at the first frame Z1, theta 1, what's the omega 1? 0, 0, 1, right? Because Z direction is in Z0 direction, 0, 0, 1. And then I'm gonna write the other ones, 0, 0, 1 as well, 0, 0, 1 as well, correct? All three of them are in the same direction, so I wrote all my omega I. Now for QI, was it Lizzie that asked the question, or also Demi asked the question about how do you calculate VI, right? Why is it this negative direction? So I posted centripetal force and rotational motion in Discord. So anytime you have rotational motion on the tangent of that path, that rotation, that angular velocity is going to create a linear velocity, right? If you are going counterclockwise, let's say this way, in here your velocity is down. But if this is the same joint, but I'm measuring here, it's going up, right? So it is important where the reference frame is. But since our reference frames are always on this side, the robot expands on that side, it's always a negative direction one. And it's usually this distance, how much is offset. So for the first one, what is QI? Q1, 0, 0, 0, because in the Y0 direction, there's no offset. We don't care what is in the other one. There is a value called X. It's not going to impact. So I'm going to say, so this is L0 here. For those of you that say, no, we should have a number is X. Let's say this is 0, 0, X plus L0. Let's say that. Still, when you calculate VI, is going to be 0, 0, 0, because that does not impact if you're doing cross product. So if in the exam you showed and you said that this distance does not impact, it's okay, I accept it, right? So you have to communicate well. For Q2, how about Q2? 0, L1 is what will impact plus the Z. You can put 0, you can put X plus L01. So I'm going to say X plus L0 or 0, since does not impact, doesn't have impact on VI. So I'm going to put 0 here. And then for the other one, 0, L1 plus L2, right? That's how much offset you have. 0 or that number. So, well, since I did that, now if someone is not here, they're going to be confused. I'm going to put A. Doesn't matter. Then this one, if you do the calculation in L1, 0, then is L1 plus L2, 0, 0. If you don't believe me, follow omega I cross product QI for this two, and you will see that that A does not show up. Now for the last bit, now for theta 4, what's our VI? You remember that this is the direction of the velocity, right? I don't think so. Huh? I don't think so, because so you have the bring what is cross product? So here, double negative is going to be in the positive. It's hard how to think, right? Yeah, thank you. All right. Then for VI, what's VI? What's V4? Huh? 0, 0, 1, because it's the direction of V, right? And it's in the direction of your Z0. 0, 0, 1. Now, now I have to write the screw axes. S1, S2, S3, S4, and these come from and so assume I wrote this. So the annotated version have those. You end here because that's all I asked. Right? Now, the question is not too difficult, but you see that there are a couple of things that you need to pay attention to, otherwise everything is wrong. Now, so this is the end of like the exam review. Now, the thing is, all these questions, I'm not going for being difficult or have like 70% average like other professors or blah, blah, blah. I don't care. things that I know, I think you should learn and you should know by just looking, and you don't have to think about it, you don't have to look at your lecture slide. These are the kind of questions, because then when you're solving a programming assignment, you should have them in your memory, not memorized, you should have learned them. Now, next week we are working velocity kinematics. We're gonna take one notch up. It's gonna be like differential equation and whatnot. So this exam really is like you studied, you promised that you understood everything, because you're changing the gear to something else. Then you will come back to this, all right? So question will be fundamentals like this. Looks simple, there's a few. Now, for some of you, before you leave, I promise one quick thing. I had a few typos between my lecture when I was writing transformation matrix and M matrix, so I didn't put one there. That's a very example for that. So wherever you have vector, if you are fixing it, it's 0, 0, 0. So sometime when I wrote my bracket as I put 1. It's not 1, they're all zeros. If you write your M, it's going to be 1. If you write your transformation matrix, it's going to be 1. Trust the formula, not if I might have mistake in my example. That's why I say you should bring formula only. The formula is correct. So if you found a typo, check what the formula was and say, Dr. Z made another mistake. Haha. Okay.
Okay.
So trust the formula. All right. Thank you. Enjoy your weekend.
That's okay. Check my